Okay, in our last class, we discussed about some non-ohmic conductors like diode, filament, thermistor, LDR, and we also practiced some questions from the topical past papers related to different types of circuit, including the combination of resistance and the combination of LDR diode in different form in different questions. And today, first of all, we are going to add one more topic of potential divider because in our past papers questions, we have so many concepts related to potential divider. Potential divider is very easy and it is like series combination idea, but still we need to know about the formula, how we can apply direct formula of potential divider and why we use that direct formula for potential divider. So before starting question, if we first talk about potential divider concept, so basically the purpose of potential divider by name, it means to split the voltage or to divide the potential difference or the voltage among the components connected in the circuit. Especially it is only for series circuit, it is not for parallel circuit. So potential divider only works for series combination. Because we already discussed in series and parallel combination that in series combination current remains the same, but voltage divides or potential difference of the components or among the components divides or splits. So that's why this potential divider only works for series combination. So when you observe that circuit is given in series combination, so then we can apply the formula of potential divider. Otherwise, on parallel combination, it is not applicable because voltage is always same in parallel combination. So the purpose of potential divider is to split or divide voltage among the components connected in series combination. So this is the purpose of potential divider because in past papers sometimes they used to ask about to define potential divider or what is potential divider like this. And if we consider a very simple circuit, for example, we have one resistor and let's suppose one lamp. So it may be like any component in the circuit. So it is not compulsory that always we have lamp and resistor. It depends. You can connect any component in series combination and apply the formula of potential divider. So in this combination, the resistance of the first resistor will be like R1 and the resistance of lamp is R2 and the EMF of the battery is, let's suppose, 9 volt, and we have voltmeter connected with resistor. So in this combination, this is the setup of potential divider. And in series combination, we know one thing, that current remains the same. Current remains the same. And EMF, which is 9 volt, it splits into voltage of or voltage across resistor and voltage across the lamp. So V1 is for resistor R1 and V2 is for lamp. So it depends upon the voltage shared between these two components. Now voltmeter is connected with resistor. And in most of the questions, they used to ask like find out the voltage or find out the reading of the voltmeter connected with the component given in the circuit. So right now in this circuit, voltmeter is connected with R1 and we have to find out the voltage of only one component. So we have direct formula. Let's suppose if you want to solve for the output voltage, so you can apply direct formula. Direct formula will be like this. V output, it means output voltage is equals to resistance of the component R1. So always remember you have to place your resistance value that is connected with the voltmeter. So let's suppose a voltmeter is connected with R2. So we have to place R2 in numerator. And like in this diagram, voltmeter is connected with R1 or the resistance of the first component. So we have to place R1 in numerator. So we have to keep the quantity in numerator with which the voltmeter is connected in the circuit. And we have series combination R1 plus R2 multiplied by input voltage. So this is the direct formula, direct equation for potential divider. You can apply in any question to solve that question in short time without making any combination, without making any setups according to the given diagram. So you can just direct apply this formula and you will get any unknown quantity given in the equation. But one more thing, we know that in this series combination, the value of current is same. So we have current passing through the resistor and current passing through the lamp. So we know that current remains the same. So we can also use another formula. Let's suppose the total voltage formula. Total voltage is equals to current into total resistance. So you can also use this equation depending upon the situation of the question, because sometimes we have different scenario. You have to find out different quantity that cannot be solved with the help of direct potential divider formula. So we know that in this formula, we can use total EMF value, total resistance value to find out electric current. So in this, we have to add both resistance. So in this way, we can make equation according to the scenario, right? Any confusion in potential divider? Okay.
Sir, can you repeat about the other formula thing you said?
First one or second? First one?
Second. No,
Second.
second.
Okay, basically sometimes we are not able to apply the direct formula potential divider, right? So we have another choice. We know that Ohm's law, and right now the components connected in the circuit, we can apply Ohm's law on it. So this is the simple formula of Ohm's law. V is equals to IR. And VT means total voltage. Total voltage means EMF. I, the value of electric current. Electric current remains the same. So that's why we just only used to write I, because it is always same in the series combination. And then we have total resistance. So we have to add the resistance of R1 and R2. So then we are able to find out the value of RT. So in this way, we can also use this equation, this Ohm's law formula, to find out any unknown quantity given in the circuit, right? If we are not using the first equation, that is of potential divider, right? This is the difference.
We got it.
Yes. And now if we apply this formula on the question, so let's see how to apply and what type of question related to potential divider we have in past papers. Okay, this is one question. In this question, you can see we have series parallel both combinations given. Question number 7, figure 7.1 shows a circuit that contains a battery, a switch, voltmeter, and three 40 ohm resistors R1, R2, R3. So resistance of all three resistors are same, 40 ohms, 40 ohms, 40 ohms. And switch is open. As you can see in the diagram, we have one resistor connected with the switch. Switch is open, it means R3 is not the part of the circuit right now. R1 and R2 forms a potential divider. First of all, definition of potential divider, as we already discussed in the notes. So you just copy paste the same idea over here. Potential divider is like components connected in series and voltage divides among or splits among the components connected in series combination. B part, the reading on the voltmeter is 7.5 volt. Calculate the EMF of the battery. So voltmeter,
What's the second one?
this is 7.5. And R2 is also connected in the circuit. R3 is not connected because switch is open right now. So EMF will be the sum of the total voltage. And as we know that all resistors have same value. So they have same share of voltage also in series combination. 7.5, 7.5, right? And because of this, total voltage or EMF is equals to
7.5 plus 7.5,
15.
15.
Now switch is closed. Calculate the resistance of the complete circuit. Total resistance.
You can use the formula.
And in the last class, as we discussed, we have to solve in pairs. First of all, we have to solve R2, R3, then with R1. So R2 and R3 are in parallel combination. So we have to use the parallel combination formula first. So this is R2 and R3. 1/40 plus 1/40.
2/80.
2/40. Or if we flip the values,
1/20.
so when we flip the values, so R23 is basically equals to 20 ohms. Because in formula we have reciprocal, so we have to shuffle the value to get the round off value without fraction.
And you bring it to the numerator to be 20.
Yes. And finally we have R1 connected in series. Because when we join R2 and R3, they become like a single resistor and that is connected with series in series combination with R1. So R1, 2, 3 is equals to R23 plus R1. 40 plus 20. 60 ohms. C part, calculate the reading on the voltmeter when the switch is closed. Now switch is closed and we have to calculate the value or reading on the voltmeter. And as we discuss, voltmeter is connected with R1 just like the circuit we discussed. So for example, if you want to apply this formula of potential divider, so you can use this formula, but before that we have to make some number calculations. Like if we make this simple circuit, we have R1 connected and finally we have voltmeter connected with R1. This is only R1. This is R23 because we already discussed that R23 are in parallel combination. So if we combine them, so we have combined value of resistance that is 20 ohms and this is 40 ohms. So this is the difference between the first and the second circuit after combination. So now this circuit is easy to solve as compared to the given circuit because in the first circuit we feel complicated in the sense that what to do with R3. So just take combined resistance of R2 and R3 because it will give you a simple series combination circuit like potential divider. And you already know about EMF, which is 15 volts, and this value is unknown output. And according to the formula, you can apply the direct equation R1 over R1 plus R2 into input voltage, which is EMF. R1 is 40, 40 plus 20 multiply by 15, 60. Final answer 10.
Yes, 10 volts.
So it means that the first resistor takes 10 volt out of 15 and rest of the 5 volt will be transferred to the second component, which is combination of R2 and R3. So in this way, we have complete question related to potential divider for 8 marks. Okay, question number 8. Again, we have electrical circuit just like potential divider, but we have different components now. Light intensity at the circuit increases from dark to bright. State any effect on the resistance of component Y. So light intensity increases from dark to bright. So state any effect on the resistance of component Y. So Y component is LDR basically because we have light marks given light dependent resistor LDR. So in LDR you remember that when intensity increases resistance decreases inversely proportional. So bright means resistance decreases and voltage also decreases. So it means the value of the voltmeter or the reading on the voltmeter will be less or it will be decreasing. So we can say that resistance decreases. And in the second part, any effect on the reading of voltmeter. So as we discussed, when resistance decreases, voltage also decreases. So at high intensity of light,
The resistance decrease.
resistance decreases and voltage also decreases. Or you can write like the reading on the voltmeter also decreases. Part B, the circuit shown in figure 8.2 is a switch on for 2 minutes. The current in the 4 ohm resistor is 3 ampere and the magnitude of the charge on an electron is 1.6 exponent minus 19 coulomb. Calculate number of electrons that pass through the resistor each second. So we have to find out number of electrons. So how to find out number of electrons? Basically, first of all, we need to know about the charges. Time is 2 minutes. Resistance is given. Electric current is given. And the charge of one electron is also mentioned. And we have to find out the number of electron passed through resistor each second. So we have to convert time into seconds. So first of all,
That is 16 million once we find the answer.
yes. First of all, we have to find out the charge. Very simple. Current is 3 ampere. 2 into 60. 360. And after finding out the total charge, we can divide with the value of charge of one electron to get the total number of elect. Okay, so we were talking about the number of electrons to pass through the resistor each second. So for number of electrons, 360 divided by 1.6 exponent minus 19. That is equals to 2.25 exponent 21. So these are the number of electrons available in this conductor passing through resistor each second. Then we have to calculate the power dissipated by the resistor And as we discussed already that the formula of power P is equals to VI. This is the formula of power and energy. So we can use the formula P equals to VI to calculate power, and there are other forms of power also. So it depends upon the quantity given in the question, whatever the quantity given in the question. So you can use that formula value of the question to find out the final answer. So we have a value of electric current given, we have voltage given also. So we can apply the simple formula P equals to VI, and the voltage equals to 12, and the value of current 3 ampere, 36.
30.
Yes, 36 watt. So this is another question for 8 marks, just like the previous one. Okay, another circuit you can see, same like the pattern of potential divider. Again, we have question number 8 that shows a circuit and state the name of the component X. And this is the same component, just like the second last question we discussed. So the name of the component is LDR,
Yeah, LDR.
light dependent resistor. The potential difference across component Y is measured with voltmeter. On figure 8.1, draw the symbol for the voltmeter and its connection to the circuit. So it's very simple. Now you have to draw voltmeter by yourself, and it is connected with component Y. So this is the diagram. And now you can see we have voltmeter connected with lower component. In the previous questions, we have component voltmeter connected with the top component or the first component in the circuit. Now it is connected with the second one. EMF of the battery is given. EMF is 12 volt. Component Y has resistance of 400 ohms. In a brightly light room, the resistance of component X is 350 ohms. Calculate the current in the circuit. So now you can see we have different question. We have to find out current in the circuit. But we know about input voltage, like total voltage of the circuit EMF, component Y. Resistance of Y is given. Resistance of X is given. And it is a brightly light room. It means resistance will be low. And you have to find out the value of electric current. And we don't know about the value of the output voltage for the voltmeter. So this is the question. Like you can apply different formula to find out the current in the circuit, just like we discussed. So we can use the formula total voltage equals to electric current and total resistance. Because current remains same in series combination, so the total voltage is 12, total resistance 400 plus 350, or we can write 16 milliampere, right? So this is the value of electric current that remains same throughout the circuit. Now in the second part, calculate the potential difference across Y. Now this is the same question like the potential divider formula, because with component Y, voltmeter is connected. So it means they are talking about output voltage. So we can use the formula of potential divider. Resistance of Y multiply by input voltage. Input voltage is 12, component Y 400 divided by 750. 6.4 volt. In a dark room, the resistance of the component X is very large. State the effect this will have on the potential difference across component Y. So we know that component X is LDR, and they are saying in dark room resistance is high, so definitely voltage will also be high. And the share of the voltage for X will be increased, but the share of the voltage for Y will decrease. So this is the difference. So we say that it decreases, and in B part suggest a practical use of component X. We mention in the notes also, we use in automatic street lights and in security alarm system also. So we can use in security alarm or street lights. Any question in this? Any confusion?
No.
Okay. Because you observe that like these last three questions are almost similar in the pattern, only some components connected in the circuit are different, and the quantity they are asking about is different in the question. Otherwise, the pattern and the formula we are using are same, uh, just like the previous questions we discussed. And circuits are also like the same of potential divider circuit.
So, are there any MCQs for this lesson paper?
Basically, we have MCQs also, but we will discuss MCQs in next class, because in MCQs there are like mixture of one or two more topics. So that's why first we are doing practice of the circuits in the theory paper. Because in MCQs we have like given options, so we need to solve or we need to do working in the rough side work, then we will check the final answer. So with the help of theory questions, we can practice those equations and identify the circuits. So then it will be easy for us to solve MCQs directly. Okay. Okay, one more question, but this time we have different category of the question from the last three questions. Question number 9 shows current potential difference graph. It means current voltage graph for a resistor, thermistor, and a filament lamp. So three components are connected as mentioned in the graphical representation. Now, the resistor, thermistor, and filament lamp are connected in series with a power supply. Draw a circuit diagram for this circuit. So it is very simple. We have components of potential difference, definitely battery or cells. We have resistor, thermistor, filament lamp, and all are connected in series combination. So series combination is very easy to draw. Resistor, thermistor, and filament. Now in second part, add a voltmeter to your circuit diagram in a correct position to measure potential difference across the resistor. So we have to connect voltmeter only with resistor like this. Now, third part, using the graph in figure 9.1, determine the potential difference across the terminals of the power supply when the potential difference across resistor is 6 volt. So now you can take the help from the graph and find out the potential difference across the terminals of the power supply. It means the total voltage basically when the potential difference across resistor is 6 volt. So the resistance is given only, which is 6 volt, and the other components are unknown, and we have to find out the voltage of thermistor and filament lamp. So basically two quantities are unknown. And you can see this question is for 4 mark. And we know one thing only, that it is in series combination. So current remains the same. Resistance of, sorry, voltage of resistor is 6 volt. So this straight line is the graphical representation for the resistor. And on 6 volt, the current is 0.4. So the value of current is 0.4 and the voltage is 6. Now, as we discuss in series combination, the value of current remains the same. It means that if you draw a horizontal line, so you can see we can find out the points intersecting with this horizontal line for other components. and we can find out the value of voltage from the graph easily. This is the value for filament lamp, and this is the value for thermistor. Because current remains same, so if the current for resistor is zero point 0.4 ampere according to the voltage given in the question, and if we draw a horizontal line, because in a horizontal line current remains the same, so that line crosses through the other graphical representation of the components, and we can mark the value of the voltage given in the graphical uh, axis on x-axis. So we have different results. First one is for filament, which is 3. Second one is thermistor, 369. So current is same and the value of current is 0 0.4 ampere from graphical representation. If you want, you can do like mathematical calculation to find out individual voltage and finally add them. Otherwise, from graph, you can also find out the value directly. So you don't need to perform calculations, and you just simply find out the value from the graphical representation very easily. Resistance of filament, sorry, voltage of filament, voltage of resistor, voltage of thermistor, and the total voltage or EMF 3 plus 6 plus 9. Final answer 18. And again, describe a practical use for a thermistor. Thermistor basically used for uh, the temperature based component. So it depends upon the temperature. So when temperature is high, resistance is low. And when temperature is low, resistance will be high. So it can be used in security alarm system related to the thermal energy. So this is another question related to the electricity concept. This is also the same type of question. Question number 8. Circuit contains two fixed resistors and LDR. It shows that power supply is a 9-volt battery. And the current in the 450 ohm resistor is 0.012 ampere. What is meant by electric current? So definition of electric current. Rate of flow of charges. The current in the LDR is I1 and the current in 8 ohm resistor is I2. Complete the equation that relates the current in 450 ohm resistor to I1 and I2. So you just need to write the equation that shows you relation for I1 and I2 in the component 450 ohm resistor. So if we consider the circuit again, so what do you think? What will be the value of current for 450 ohm resistor? Because current passes from the left hand side, so electric current starts to flow from this direction, and this maximum value of current passes through 800 ohm resistor, but after that it divides into two different paths, and the current passing through LDR is I1 and current in the 800 ohm resistor is I2. Now we have to relate this equation. So we know that current passing through I2 is the total current passing in the circuit because that is connected in series with the battery, and 450 ohm and LDR are connected in parallel combination. So these two are in parallel combination only. So in parallel combination, current will not remain same. So it means current divides between these two components in the circuit. So the value for or the current in 450 ohm resistor will be equals to I2 minus I1, right? Because I2 is the maximum value of current passing from the battery and I1 is the split value of the current, because in parallel combination current divides. So this is one part of the electric current and the rest of the electric current will pass through 450 ohm resistor, right? So that's why I2 minus I1 will gives you the electric current passing through 450 ohm resistor, correct? And in C part, calculate the power dissipated in 800 ohm resistor. So 800 ohm resistor resistance is given. Electric current is also given. So we can use the formula of power related to electric current and resistance. P is equals to I square into R. But the problem is the value of current is unknown. Sorry, the value of current is given, but that is for only 450 ohm. So it means we don't know about the value of electric current. So first of all, we have to find out the value of electric current. Otherwise, it will be not possible to calculate the power. So first of all, we already know about the total voltage. Total voltage is 9 volt. And if we talk about the total resistance, but the problem is resistance of LDR is not given. Resistance of LDR is not given, and the current passing through 450 ohm resistor is given. So we have to do another thing. We have to calculate the voltage of 450 ohm resistor. Because if we find out the resistance, if we find out the voltage of 450 ohm resistance, so because of parallel combination, their voltage will be same. So out of 9 volt, we can find out how much volts pass through this 8 ohm resistor and how much volt we have across 450 ohm resistor. So that's why we are finding out the voltage of 450 ohm resistor. Current is given, resistance is also given. Value of current 0.012. Resistance is 450 ohms. 5.4. 5.4 volts is the voltage taken by one resistor, and this will be same for uh, the component LDR, because LDR is also connected in parallel combination. For 800 ohm resistor, out of 9, 5.4 is taken by one component, and rest of the value 3.6. So finally what happens? Power dissipation will be P equals to V square over R. Three point six square divided by 800. So this is the value of the power we are getting from this calculation, because we use the third formula, right? So these are some more questions related to the electricity and electrical circuit components. So you can also practice the rest of the question from this worksheet, and in next class we will also start practicing the MCQs question from electricity only, right?